Hello everyone, we the students of GRIT have come up with a project titled Towards Effective Bug Triage with Software Data Reduction Techniques. We are batch number D2 and we have done this project under the guidance of Assistant Professor Mr. N. Vijay Kumar. Before we move on towards the project, I would like you to brief on the title. Towards Effective Bug Triage. Bug is something which stops the program for running properly. Triage is an action of sorting items according to quality. Bug triage means sorting the bugs according to its quality and density. And how do we do that? We do that with the help of software data reduction techniques. Data reduction. It is the process of reducing numerous amount of data into simpler ones. Let us see what we have in our existing system. Firstly, we investigate the relationship in bug data and report network to examine the dependency among bug reports. After knowing the relationship among them, we actually develop a network. In the proposed system, we address this problem of data reduction for bug triage. That is, we reduce the bug data to save the labor cost of developers by using different algorithms and instance selection and feature selections. System requirements. The hardware requirements here are a dual core processor, a 40 GB hard disk, 512 MB RAM, and the software requirements are Windows XP, Java, NetBeans and MySQL. This is our system architecture. As we can see, when a bug is occurred, it is reported to the developer and the developer checks whether it is a new bug or an existing bug. Once the bug is assigned to the developer, it performs two selections, the feature selections and the instance selections. Next is the flow diagram. Firstly, we extract the bug dataset, train the bug dataset by using feature selection and instance selection, classify the bug dataset and form a new dataset which is then stored in the database. A developer, before a bug being reported to it, it registers itself in the database, after which it checks whether the bug is a new bug or an existing bug, after which it again uses instance selection and feature selections. After the bug is being triaged, it checks whether the problem is resolved or not. Once the problem is resolved, it goes and sets in the performance graph and the process stops. If it is unsatisfied or unresolved, the bug goes to a new developer. And again the same process continues. Here we come to the sequence diagram. In this process, we have three major key roles: a manager, a team leader and a developer. A manager recruits a developer, assigns bugs to a developer and checks the updates in the database. A team leader recruits a developer, identifies and checks for a new bug and adds the bugs to the database. It also gets updates from the repository. A developer registers itself in the database and also checks for the assigned bug. It rectifies the bug and updates the status in the database. Here we come to the execution of the process. This is a window where we load the dataset collection. We firstly browse the dataset. This is an unstructured way of the dataset. Here we load the dataset and convert it into a structured one. As we can see, all the dataset had been in a format, in a structure. In the pre-processing, we'll remove the noisy and duplicate data. After pre-processing the data, we go for the instance selections. We can choose the data according to our components. As we can see, this is the GPA, this is the MRSC, the UI. After the instance selection, we go for the feature selection of the data. In the feature selection of the data, we get the whole collection of the data at once. After the selections, we do the analysis of the bug report. As we can see, we have an open bug report, the closed bug report, the rectified bug report, the reopened and the assigned bug reports. After the bug report is analyzed, we then put the status for the bug rectification. For this, we need to enter a bug ID, the bug summary, the resolution and the status. In this status, we keep whether it is rectified, and in case if it is unrectified, we choose the unrectified option. After submitting the rectified and the unrectified bug status, we can also trace the bug history. We have the new assigned bug history and the rectified bug history. In the new assigned bug history, this can be used for our future reference. And in the rectified bug history, where we have all the information about the bug and which can be used for our later purpose.